There is a star out there that could end everything. Not a metaphor, not a movie plot. A real star in our galaxy, close enough that astronomers have actually run the numbers. The question is not whether stars like this exist. They do. The question is whether any of them are aimed at us. And what aimed at us even means when we are talking about something that burns 1,000,000 times brighter than our sun. By the end of this video, you will have your answer, and I promise you it is stranger and more unsettling than you expect. We spend a lot of time worrying about asteroids, about solar flares, about things inside our solar system that could go wrong. But there is a category of threat that sits further out, quieter, and in some ways far more absolute. It comes from other stars. Most stars in our galaxy are harmless to us. They are too far away, too stable, too ordinary. But some stars are not ordinary at all. Some stars are so massive, so energetic, so unstable, that if one of them sat where our sun sits right now, the Earth would not just be uninhabitable. It would likely be stripped of its atmosphere within decades. And a handful of those stars are close enough, astronomically speaking, to matter. Not all stars are created equal. Our sun is a yellow dwarf, medium-sized, middle-aged, well-behaved. It will burn steadily for another 5 billion years or so. Now imagine the opposite of that. Blue hypergiant stars, the most massive stars known to exist, burn at temperatures of 50,000 degrees on their surface compared to our sun's 6,000. They are so luminous that the light itself exerts pressure. Radiation pressure so intense it actively blows material off the star's surface. That outflow, called a stellar wind, is a constant stream of charged particles blasting in every direction. Our sun does this too, mildly, but a hypergiant stellar wind is tens of millions of times stronger. If you placed one of these stars where our sun is, that wind alone might erode our atmosphere over thousands of years. But that is not even the main event. The main event is what happens when they die. When a massive star reaches the end of its life, which happens fast because the bigger they burn, the faster they die, it collapses and then explodes. A supernova. In a fraction of a second, a supernova releases more energy than our sun will emit across its entire 10 billion year lifetime. And some supernovae do something even more extreme. They focus that energy into two narrow jets of gamma radiation, a gamma-ray burst, traveling at nearly the speed of light. A gamma-ray burst pointed directly at Earth from within a few thousand light-years could strip away our ozone layer almost instantly. Without the ozone layer, ultraviolet radiation from our own sun would render the surface of Earth uninhabitable within years. This is not science fiction. There is a hypothesis, still debated but taken seriously, that one of the great mass extinctions in Earth's history may have been triggered by exactly this. A gamma-ray burst from a distant star, the kill zone for a gamma-ray burst, the distance at which it could cause a mass extinction, is estimated at somewhere around 6,000 to 8,000 light-years, depending on the burst. Our galaxy is 100,000 light-years across. That is a significant fraction of our cosmic neighborhood. So, are there any stars close enough and dangerous enough to actually worry about? Yes. The most famous candidate is Eta Carinae. It sits about 7,500 light-years from Earth. It is one of the most massive and luminous stars known in the Milky Way. Possibly 200 times the mass of our Sun, Eta Carinae already had a near supernova event in the 1840s. For a few years, it became the second brightest star in the sky, visible in daylight, without actually exploding. That was just it burping. When it actually goes supernova, and it will, possibly within our lifetime, possibly in 100,000 years, we genuinely do not know, it may produce a gamma-ray burst. Is it pointed at us? The current best estimate is no. The poles of Eta Carinae, where a gamma-ray burst would emerge, appear to be oriented away from Earth. But appear to be is doing a lot of work in that sentence. Then there is WR104, a Wolf-Rayet star about 8,000 light-years away, also a strong supernova candidate. For years, astronomers debated whether its rotational pole was aimed directly at Earth. More recent analysis suggests we are probably fine. Probably. That word keeps coming up. Probably. Let us talk about distances for a moment, because they matter enormously here. The nearest star to us, Proxima Centauri, is about 4 light-years away. Even a supernova at 4 light-years would be catastrophic. Overwhelming radiation, atmospheric damage, the works. Fortunately, Proxima is a small, quiet red dwarf with no supernova potential. For a genuinely dangerous supernova, something that could cause real damage without a gamma-ray burst, the threshold is estimated at around 25 to 50 light-years. There are no supernova candidates within that range. For a gamma-ray burst to be extinction level, we probably need to be within a few thousand light-years and directly in the beam. Eta Carinae and WR-104 are in that range. The beam alignment is the variable we cannot fully confirm. Think of it like this. A gamma-ray burst is not an explosion in all directions. It is more like 2 blowtorches firing from opposite poles. The explosion scatters everywhere. The blowtorches go specific places. Whether Earth is in that path is the question. Here is where the honest answer gets complicated. The probability of a gamma-ray burst hitting Earth from a nearby candidate star in any given century is extremely low. Some estimates place a serious gamma-ray burst event in Earth's history at perhaps once every few 100 million years. On a human timescale, your lifetime, your children's lifetime, the risk from any specific known star is effectively zero. But here is the perspective shift that makes astronomers pay attention anyway. We do not know every star in our galaxy. We do not know the exact orientation of every nearby stellar pole. And geological and fossil records hint that something very large has hit the reset button on life before, at intervals that are hard to explain with just the threats we already know about. The universe has done this before. That is simply true. So, is there a star that could destroy our solar system? The honest answer is yes. There are several candidates, Eta Carinae and WR-104 being the most discussed, that are both massive enough to produce a civilization-ending gamma-ray burst and close enough that we would be within the danger zone if the beam aligned with Earth. The probability that this happens on any human timescale is very low. The orientation of the most threatening stars appears, probably, to spare us. But we are working with incomplete information, limited by the distance between us and objects that would kill us before we saw the flash arrive. Because that is the other thing. Light from Eta Carinae takes 7,500 years to reach us. If it exploded and fired a burst in our direction right now, we would not know for 7,500 years. The sky you see tonight is already 7,500 years out of date. In that direction, you are looking at history. That is not a reason to panic. It is a reason to find the whole thing extraordinary. We live on a small rock, circling an average star, in one arm of a galaxy that contains hundreds of billions of others. Some of those stars are monsters, and by an accident of distance and geometry, we are for now safe. For now. If you want to keep falling down this rabbit hole, and there is a lot more to fall into, subscribe. There is a video coming up next on what would actually happen in the hours and days after a nearby supernova. The answer involves some genuinely surprising things that scientists only worked out recently. Do not miss it.